Alrighty. So, we're going to learn another method today, which is good. And then tomorrow we'll take a quiz. And then next week we'll finish up Unit 5. And then we'll test on Unit 5 on the 24th of February. Okay? So, a week and a half we're going to have a test. Okay? 3 things to accomplish today. We got some notes. We're going to hand some stuff back. And then hopefully give you some time to work on some homework. Okay? Alright? Alrighty. Let's get into it. So, on page 23 of your notes, solve that system graphically. Tell me what the solution is, for 1. And then in number 2, just write me the inequality. Okay? So just write me the inequalities. Okay? Go for it. Deal with the first one first. Y equals 2/3 x plus 6. That has a y-intercept of 6. 1, 2, 3, 4, 5, and 6. It has a slope of 2/3. So that means rise of 2, run of 3. So that is up 2, right 3. Or down 2 and left 3. Down 2 and left 3. Down 2 and left 3. And so on and so forth. That then would give us a solid line. Looks like that. Yes? Yeah. Okay. All right. Then the second one would have a y-intercept of -3. Slope again of 2/3, so that's up 2, right 3, up 2, right 3, up 2, right 3, or down 2 and left 3, down 2 and left 3, down 2 and 1, 2, and 3, left 3. Do those lines intersect? No, those lines do not intersect, so therefore there is no solution. And that would be the answer. Okay? Just putting nothing is not an answer. That's leaving it blank, and therefore you get no points. Okay? You gotta write down no solution. Okay? If they landed on top of one another, so if the lines, if we ended up graphing basically just one line, if they landed on top of one another, what would that answer be? Infinite solutions. Yeah? Okay? Infinite solutions. All right. Write an inequality to represent this context. Fernando plans to donate at least $20 of the money he earned doing work for the neighbors over the summer to 2 different fundraisers at school. Okay. So, X and Y. And then Y would be money to the second fundraiser. Okay, so if somebody give me an inequality, let's donate it at least $20. Like that? Agree with that? told you not to do it, but some of you kind of did. Give me something that would work there. How much money would he give to the first one and the second one? That doesn't answer any of the questions. I could throw out random numbers too. 85. What do you got? 10 to each? Yep. So if he donated 10 to each, okay, that would work. Give me another one. 25 and 30, 25 to one, 30 to the other. Yep. Those would all work. Okay? Alright. Love it. So today we're going to shift gears a little bit. So we've been talking about Carlos and Clarita and their pet boarding business. Well, we've been talking about, we had spatial. We had to deal with how much space that they had to use. Then we had to deal with how the cost of their startup business, the cost of to start it up. Getting the pet run or the cat runs and the dog pens or whatever they were called. Okay? Then we had to deal with time in terms of they only had so much time to feed and walk them. And then they only had so much time to pamper them. Okay, so we had those four. Today, we're going to shift gears a little bit because now all these animals need to get fed. And so they have money. Or I shouldn't say they have money. They're going to need food. Okay? All right? So in problem number 1 here, 1 week, Carlos bought 3 bags of Tabitha Tidbits and 4 bags of Figaro Flakes for $43. The next week, he bought 3 bags of Tabitha Tidbits and 6 bags of Figaro Flakes for $54. Based on this information, figure out the price of 1 bag of each type of cat food and show all of our work. Okay? All right? So we need to figure out what? What do we need to figure out right from the jump? Of each type, right? Okay. So that means one variable is going to be the Tabitha Tidbits price, right? And the other variable is going to be Figaro Flakes price, right? Okay. So we're going to need to write that down. Okay. What do you want to use? X and Y? Okay. X, what do you want it to be? Tabitha. Agree with me on that. I want to write this down. Wake up. Let's go. You can do it. I promise. We're over here. Okay? All right? Now, let's go back and reread the problem and see if one of the sentences comes up with an equation for us. Is this going to be an equation or is this going to be an inequality? It's going to be an equation because we know that Carlos spent $43 1 week, and we know that he spent $54 the next week. Okay? So this is going to be an equation. Okay? So 1 week, Carlos bought 3 bags of Tabitha Tidbits and 4 bags of Figaro Flakes. How's that going to look in one of my equations? 3x plus 4y, yep. Okay, and that's going to be what? How much did that cost him? $43. Okay, so that's one of my equations. 3 bags of Tabitha's Tidbits. Good catch. 3 bags of Tabitha's Tidbits plus 4 bags of Figaro Flakes cost me $43. Okay? What's the second equation going to be? Because if I define 2 variables, I got to have 2 equations. Is that what you were going to say? Hey? Is that what you were going to say? Because didn't you start talking to him? Yes, you did. Don't lie to me.
I was helping, but
Yeah.
I wasn't going to say that.
Oh, okay. You were going to say it? What were you going to say?
I was going to talk to it.
Oh, okay. I thought you were talking about 3 bags and 6 bags. 3x plus 6y equals, you said 54? So now we got two equations. Now if we solve for x, that's going to be what the price of Tabitha's Tidbits is going to be. And when we solve for y, that's going to be the price for Figaro Flakes. What's happening?
If you subtract the 43 from the 54, wouldn't you get 2y? Yeah, that's actually smart. I was thinking that too.
We had turned 3 pages ahead of us. Okay, all right. So we're getting there. I promise. I wanted to say one thing before we did that. Okay. Now we've got two different ways right now in our toolbox to solve this equation or solve this system. Right? We could graph it, or we could substitute it. Right? If I wanted to substitute it, I'd have to solve one of the equations for one of the variables. Right? Well, does 43 or 4, can that be divided nice by 3? No. What about 43 and 3 divided by 4? No, right? Okay. What about 54 divided by 6? Yeah. Okay. 54 divided by 3. So maybe we could do the second one. But if we don't see that, we got to have a third tool in our toolbox. And that third tool is going to be the elimination method. Okay? And so what we're going to do is, in the elimination method, the first thing that we have to do is we have to get same number only one's got to be positive and one's got to be negative in front of the same variable. Okay? So I need the same number, only one positive and one negative in front of the same variable. Look what we already have. We have a 3, right? Okay? So now we just got to make one of them be negative. Which one do you want to make be negative? The top one or the bottom one? Top one? Okay. So if I make this one be negative, then I have to make this be negative, and I have to make that be negative. I got to change all of the signs all the way through that line. Okay? With me? Second step in elimination is you are going to add both equations. Now, if you've got them lined up so that you have x's, y's, equal signs, numbers, then just adding them is pretty easy. Because you go negative 3x plus 3x. That's 0, so that gets eliminated. That's why it's called the elimination method, because you are eliminating one of the variables. Negative 4y plus 6y. 2y. Negative 43 plus 54. 11? Okay. Next thing that you're going to do with that, now you're going to solve that new equation. How am I going to solve 2y equals 11? Divide both sides by 2? Okay. So what does y become then? 5.50. And why do I have to go 5.50? Because we're talking money. So we got to go 2 decimal points if we got a decimal point. Okay? So that tells me right now that Figaro Flakes costs $5.50 per bag. With me on that so far? Okay. Now what you're going to do is this is kind of where elimination and substitution match back up. Now you're going to take this $5.50, and you're going to plug it back into one of your original equations and solve it for x. Okay. Which one you want to go into, top or bottom? Bottom one? Okay. So I'm going to scroll down just a little bit. So we're going to go 3x plus 6. Now instead of y, I'm going to put in 550 has to equal 54. 6 times 5.5. 33. What would you do for 3x plus 33 equals 54? Minus 33 on both sides? That's going to give me 3x equals how much? 21. Still got to solve. Divide both sides by 3. And last but not least, you always want to check your work. Okay? So this is going to be $7 a bag, right? Okay? So let's go back to our original problem now. If Carlos bought 3 bags of Tabitha's Tidbits, how much money did he spend just on Tabitha's Tidbits? $21. So we're sitting here and he's got $21 in the first week. If he buys 4 bags of Figaro Flakes, how much money is he spending? $22. $21 plus $22 is $43, and that's how much he spent the first week. So it checks out in our first sentence, first equation. Second week, he bought 3 bags of Tabitha's Tidbits. We said that was $21. But now he bought 6 bags of Figaro Flakes. 33. 21 plus 33 is 54, which is how much he spent the last week. So it costs $7 for Tabitha's Tidbits and $5.50 for Figaro Flakes. Okay? Let's try one more. Let's do the next one. Again, using the elimination method. Okay? One week, Carlos bought 2 bags of Brutus Bites and 3 bags of Milo Munchies for $42. The next week, he bought 5 bags of Brutus Bites and 6 bags of Milo Munchies for $93. Based on this information, figure out the price for 1 bag of each type of dog food. Okay? What do we want to use for what? X and Y again? Okay, what do you want X to be? Brutus Bites? So that means then that Y would be the Milo Munchies price. Okay. Sentence number 1. Give me the equation for it. Go ahead.
2x plus 3y equals $42.
2x plus 3y equals $42. Okay? Second sentence gives me the second equation. Anybody want to take a shot at that one? 5x plus 5y? 5x plus 6y. Yep. Okay. With me? All right. So step number 1 in elimination was we got to get the same number on the same variable, only one positive, one negative. Okay? My choices are unlimited, but one choice could be I could multiply the top equation by 5 and the bottom equation by 2. And then I have the same number on x. Correct? Other one, I could multiply the top equation by 2, and then I have the same as y. Okay? Top one by 2? Okay? Except one's got to be positive and one's got to be negative, right? Okay? So I'm going to multiply the top equation by negative 2. So that negative 2 has to go into there, and into there, into all of those spots. And then that gives me negative 4x minus 6y equals negative 84. Now I've got the same number on the same variable, one positive, one negative. Okay? Step number 2 said what? Add those two equations together, right? 5 plus negative 4. 1x. The y's go away. 93 plus negative 84. 9. So I get x equals 9. Do I have to solve that? It's already solved. So Brutus, the price for Brutus bites is $9 a bag. Okay. Which equation do you want to plug 9 back into? Top or bottom? Top one? Okay. So then that's going to be 2. Oops, nope, hold on, that was green. 2 times 9 plus 3y equals 42. 2 times 9? 18. 18 plus 3y equals 42. Next step. Subtract 18. 3y equals 24? 24? Next step is divide 3. Gives me y equals 8. Well, that's it. Now we got to check it. Okay? 2 bags of Brutus bites. So 2 bags of $9 each is how much? 18. 3 bags of Milo Munchies. 3 bags of $8 each. That's 24. 18 plus 24. It's 42. That's how much he spent the first week. 5 bags at $9 a bag. 45. 6 bags at $8 a bag. Nope. 6 bags at $8 a bag. $48. 45 plus 48. 93. That's how much he spent. You now try cat leashes and dog brushes. I went X is dog leash, Y is cat brush. If you flip them around, that's fine. Okay? But you gotta have them on there so that we know which one's which. Okay? Alright? So 6 dog leashes, so that's 6X. 6 cat brushes is 6Y. And Carlos spent $45. Clarita later in the summer purchased 3 dog leashes and 2 cat brushes for $19. Okay. I'm going to go bottom equation by -2. So then that's going to give me -6x minus 4y equals -38. Top equation again was 6x plus 6y equals 45. When I add them together, my x's are eliminated. I have 2y equaling 7. Divide both by 2. Gives me y equals $3.50. So a cat brush is going to cost $3.50. I'm going to plug that back into the second equation. 3x plus 2 times 350 is going to be 19. So that's 3x plus 7 is 19. Subtract 7. 3x is 12. Divide by 3. X is 4. So $4 for a dog leash. Okay? 6 dog leashes is $24 then. 6 cat brushes is 14. Wait, no, 6. Sorry. 6 cat brushes. I went 4 cat brushes. 6 cat brushes is $21. So that gets me $45 that they spent. Works out there. 3 dog leashes is $12. 2 cat brushes is $7. That gets me $19 bill, which is what that works out to be. Okay? Now, in the one below that one, we are not going to do this problem. I'm going to just make up a system of equations on my own, and I want you to solve it. Or I want to go through the steps to solving that one. Okay? So the system of equations that I want you to do is 3x plus y equals 8. And then I want the second equation to be -6x minus 2y equals 15. which equation do you want to multiply by what number? So top equation by 2. Okay? Agree with that? Top equation by 2. So I'm going to multiply it here by 2, there by 2, and there by 2. That's going to give me 6x plus 2y equals 16. Now I can add those two together, right? Negative 6x plus 6x. 0. Negative 2y plus 2y. 0. Not, well, hold on. Okay? So on this side, I get 0, right? What do I get on the other side? No. No. 31. So we're adding them, yeah? So now what? Now it's no solution because there's no variables and there's no anything, and it's not a true statement. So this one would be no solution. Very quickly, let me show you a different kind of one. We'll go 3x plus y equals 8, and we'll go negative 6x minus 2y equals negative 16. Talk to me. Okay, it's just it's a whole other one. Okay, again, multiply the top equation by 2. That gives me 6x plus 2y equals 16. Add those together. X's, y's, numbers. And this is an infinite solutions case. When you got a true statement, it's infinite solutions. When you got a false statement without variables, it's no solution. Okay? Questions, comments, concerns, clarifications? Your homework this evening is on page 23 to 25.